Okay, so for our final example, we're going to try and come up with a full application for the iCube. And to keep it relevant, I'm going to use the example of a railroad crossing. You can really build whatever you want, but I'm trying to keep it relevant. So the first thing we'll want to do to create a railroad crossing application is identify our input and outputs. So the main input we're going to be looking at is going to be the train presence. So we'll make that input 1 here, call that presence. And the main outputs we're going to be controlling will be the 2 lights. So there's light 1 and light 2. And we'll also have the motor up and motor down for the guardrails at the crossing. So let's see, motor up and motor down. So now we've got our inputs and outputs set up, and we can apply those settings and go back to our formulas. So to start with, we'll want to make 2 oscillators to control the lights. So, and we're going to use the inverted oscillator that doesn't start up immediately when the application starts. So we're going to say whenever light 1 is on for 1 second, we want to turn light 1 off for 1 second. And that way it won't activate until we turn it on the first time. And we're going to do the same thing for light 2. Whenever it's on for 1 second, we turn it off for 1 second. Alright, so there's the 2 lights that we have. Next, what we want to do is we want to look at the train presence for when the train arrives. So when the train comes into the station or railroad crossing, the first thing we're going to want to do is we're going to want to turn on the lights and turn on the motor down for the guardrail. So we're going to turn on the 2 lights and the motor down for the guardrail. We're only going to turn that on for 6 seconds. Say that's how long it takes for it to get to the bottom. Now, the way I have it here, both lights are going to turn on at the same time, so they're going to be blinking at the same time. And that's not quite what we want, because we want them to blink on and off at a different interval. So to change that, what I'm going to do is instead of turning light 2 on, I'm actually going to turn it off for 1 second. Now, light 2 is already in an off state, but what this means is that when we turn off light 2, it means that 1 second later, light 2 is going to turn back on, regardless of what its previous state is. Normally, you would only tell an output to turn off for a specific period of time if you knew it was in an on state. But since we know it's in an off state, we can use that period of time as a delay to turn it on. Alright. And I just realized I've made a mistake right here. I was actually trying to control these outputs from the trigger condition window. That's not actually what we want. The only trigger condition we want is when the train presence is active. We want to control all these outputs. So we actually need to move these over to the action window. So I'm just going to uncheck all of them. And click OK. And redo all of that. So we want to turn on light 1. We want to turn off light 2 for 1 second. And turn on the motor down for 6 seconds. Okay. So now that covers when the train comes into the crossing. Now what about when the train leaves the crossing? So when train presence is inactive, what we want to do is we want to turn on the motor up for the crossing for 6 seconds. And just in case the motor down is still on because it was a short train or something, we'll go ahead and turn that off in case it's still on. And again, I've made the same mistake. I put the actions in the trigger condition window. So uncheck those and move them over here. So, motor up, we want to turn on for 6 seconds. And motor down, we turn that off. Now, the lights are going to keep blinking even after we've lost train presence, because if you think about a railroad crossing, they keep blinking until the arm has gotten all the way up. So we're not going to turn off the lights just yet. What we're going to do is we're going to make one last rule. When the motor up turns off, once it's already gotten all the way to the top, we want to turn off our lights. Okay. So that should be all the rules that we need. Let's go to the simulation and see what happens. Now, the first thing you'll notice is that our motor up is on, and we know that it's clearly wrong. The reason that happened is because the initial state of train presence is inactive, and we said when train presence is inactive we want to turn on motor up. So we actually need to go back and change that rule really quick. So that was rule number 4 here. And let's say we only want to turn on the motor up when train presence is inactive and the lights are blinking. So how can we do that? We're actually going to need to use an AND here for when train presence is inactive and either one of the lights are on. So we're going to have to use an OR up here between the two lights. Alright, so now the motor up won't turn on until the train presence is inactive and one of the two lights is on. So if I go back to the simulation now, we have train presence and we can see our lights are blinking properly. Motor down, it was on for 6 seconds and then it turned off. And then when the train leaves, we turn on the motor up and it should stay on for 6 seconds and then turn off. But something's gone wrong. So what we need to do is figure out why motor up didn't turn off right there. Let's take a look at what controls that. That's going to be rule number 4 right here. You can see where we turn on motor up for 6 seconds, and after that 6 seconds it should turn off. And nothing else is controlling the motor up right there. So it has to be something with this rule triggering continuously. So let's see, why would that be happening? Let's actually get a better view of this rule. We're looking at train presence being inactive, and we're looking at either one of the lights being on. So for this rule to be triggering continuously, we know train presence is inactive because we controlled that ourselves. So for this to be happening, that must mean that one of the lights, or actually both of the lights, are off at the same time, because the rule is going from a false to a true state. And the only way that can happen is if this second statement is false, because we know the first statement's true. So the two lights are off at the same time, even though they appear to be blinking so that one is always on at a time. The problem is that the simulation only has a precision of tenths of a second. The actual system will have millisecond precision for all the rules, so it might work out on a real system. But we can find a better solution. What we want to do is, instead of turning the motor up on for 6 seconds, let's just turn it on indefinitely. So we're going to set that to 0. And for our last rule, we've been looking at when motor up is off And what we actually want to do is edit that rule and say, okay, once motor up has been on for 6 seconds, then we turn the lights off. And we'll also need to add an action over here to turn that motor up off after the 6 seconds. So if we click OK there, let's go back to our simulation. And let's say a train arrives. We've got our motor down, turning on. Our lights are blinking. Motor up, down turns off after 6 seconds, but our lights keep going. That's good. And then when the train leaves, lights keep blinking. Motor up turns on. And after 6 seconds, we should see it turn off. And the lights stop blinking as well. So we know we've done it successfully. So now you know how to build some kind of real-world application. You can basically do whatever you want with it. It's really up to your own imagination. Alright then.